Welcome to Calculus BC video for skill number 234. I can use calculus to find global and local extrema. And pictured below are 9 saddles. And the trivia question for the day is, what is a 4-letter word that also ends in DLE? Alright, so skill 234 should be a pretty quick review of stuff that we learned in Calculus AB. We're looking to use calculus, specifically use calculus, to find global and local extrema. And I've written out the definition for the global or the absolute max and mins. Basically what it says is if you have a curve, we'll call that function f, and it's on the domain of D, so maybe you go from A to B. A global max on F, or a global max of F on D, will occur if some value, and we'll call that value C, is greater than all of the other values. So f of C is greater than all of the other values on the curve. Basically, it's the highest point. The global min would be the lowest point. And then you can have local max and mins. So if you had some curve that kind of went up and then dropped down and then back up, right here what we have is a local max, and here we have a local min. So this is kind of the technical definition. You're probably pretty comfortable with understanding what they are right now. The first theorem that we should make note of is that if the function is continuous on the interval from A to B, then there is definitely an absolute maximum and an absolute minimum on that interval. So no matter what your function does, somewhere between A and B, there will be a maximum. It might be a local max, or possibly it's an absolute max, but no matter what, there is a maximum. Similarly, there's definitely a minimum. Now some might argue that if we had a function like y equals 3, it's a constant function, and we're looking from this point to this point, then there is no max or minimum attained. Others might argue that the whole thing is always a maximum and always a minimum. So that's how they get around that. And if we're going to look for our local or global max and mins, we need to identify what are called critical numbers. And critical numbers of a function is a number in the domain such that either f prime of c equals 0 or f prime of c does not exist. So if we're going to look for global, local max and mins, we need to find all of our critical numbers. Either the derivative equals 0 or the derivative does not exist. So on page 234b, I kind of outlined a 4-step process for finding your global and local extrema. And the first step is to find your critical numbers, which means what you're trying to do is find when is f of x equal to 0. Then what you do in step 2 is evaluate the function at the endpoints and at critical numbers. So you have endpoints A and B, and maybe you have critical numbers 1, 2, and 3. And after you've identified or you've evaluated for all those points, one of them will stand out to be the global max, and one of them will stand out to be the global minimum. And the rest of the critical numbers have the possibility of becoming a local max or min. So what we would do is we'd create a sign chart of the intervals, and we can perform a first derivative test to identify our local max and min. So I only did one example for you, and it said find the local and global extrema for the given polynomial. And so in step 1 it says find the critical numbers. So what I did is I took the derivative, and the derivative of that polynomial is 3x squared minus 12. And I said, when is that derivative equal to 0? And I found that it is equal to 0 at plus and minus 2. So we have the value 3 -2, 2, and 5. So our endpoints and then the two critical numbers. So in step 2 we have to evaluate each of those 4 points, and I've done that in the order, and I see that the f of 2 is the lowest spot. So our global minimum occurs at x equals 2. And I'm stressing the importance of the global minimum is -21, and it occurs at x equals 2. So we need to specify the, focus on the difference between those two things. Some people might say the global minimum occurs at 2, -21, and that answers both statements, but we have to be careful that we can distinguish the difference between those two pieces. Similarly, the largest one is 60, so we have a global max of 60, and that global max occurs at x equals 5. Which begs the question, what about 3 and -2? What are those? And so what I've done is I create a sign chart of the intervals. So here I've got, basically a number line with each interval kind of blocked out with the important numbers, -3, the two critical numbers, and the other endpoint of 5. And then I perform the first derivative test on it. And when I do that, I find some number between -2 and -3. Maybe that number is -2.5. And I evaluate the derivative of that, and I find that the function is increasing. So from -3 to -2 it's going up. And then the next interval is from -2 to +2. So I find some number between there, and that derivative value is negative. So I then know it's decreasing after there from -2 to 2. And if that's happening, then I know that I have a local max at -2. And I did the last interval, I found the value is 3 between 2 and 5, and you can choose any one of them, and that tells me that it's increasing there. So after 3, the function starts to increase. So this would be a local minimum, but we actually found already that that is the local max, or global max. Global minimum. So the local minimum is the global minimum for the whole function. Alright, so this skill will probably get folded into a much bigger test where I might give you a function like f of x is equal to x to the third plus 2x squared minus 9x plus 7, and I'm going to have you sketch the curve of it. So does it do this, or where is the maximum at, where is the minimum at, where are the zeros at, all of the details of the curve. So we're going to have to identify our max and mins. We'll also have to identify our inflection points, so where does it switch from concave up to concave down, etc. So this is the end goal with this skill, is to do a nice job at curve sketching, and this is the first step heading in that direction. Alright, thanks for watching the video. You should be able to find global and local extrema, and remember there's only going to be one global max and one global min, and then you can have a unlimited number of local max and mins depending on the window that you're looking at. The trivia question was, what is a 4-letter word that ends with the letters DLE? And the answer is idle.